Hello everyone, in this talk we will introduce our recent work on image harmonization. RainNet, region-aware adaptive instance normalization for image harmonization. Image composition, which means we segment an object from the foreground image and then pass it to another background image, is a common operation in image processing, correction, and data augmentation. In general, the object from the foreground image is not often compatible with the new background in visual consistency, such as different illumination, color, hue, saturation, or texture. This visual discrepancy often leads to perceptually unrealistic compositing results. To deal with this issue, traditional methods utilize several feature statistics, the optimizing matrix, such as color, multi-scale gradients, statistical mean and variance shifts. Deep learning-based methods often directly learn the mapping network from the synthetic image to the target. Some approaches introduce segmentation loss or separate attention module to improve the network performance. However, the features are often limited in several categories and not automatically learned by deep neural networks. Also, previous deep learning-based methods focus on building more powerful convolutional neural networks, but seldom consider the connections between the background image and the foreground objects. In this work, we regard the image harmonization task as a background to foreground image visual style transfer task. Inspired by traditional methods, we learn but only learn the deep features from the background part, and then applies them to the foreground. To achieve this, we built a simple yet effective normalization module called RainNet. Specifically, we normalize the foreground features and then modulate the features with two vectors learned from the background feature. Then we combine the foreground features and the background features. In our implementations, RainNet module can be easily implemented to the existing networks and improve their performance. We choose the U-Net as our basic network, but replace the instance normalization layers in the decoder part with our RainNet. This slide gives some examples on a harmony for test insert. We compare our RainNet to other three competing methods. From the results, we can observe that our approach predicts the best results that close to the ground truth images. We also test on another real composite cases proposed by deep image harmonization. The foreground objects are passed to the background image. The results are favorable to our RainNet in terms of visual style consistency and lighting condition. We implement another interesting application in image processing. Given the input images, we use some methods to adjust the pixels of the foreground object, obtaining inconsistent visual features and unrealistic results. To make it more harmonious and realistic, we use RainNet to adaptively adjust the foreground to be compatible with the background, or transfer the neural visual features from the foreground object to the background image, making the whole image inharmonious. We measured the peak signal noise ratio for each image in a Harmony 4 test insert. Obviously, our RainNet outperforms other competing methods by a large margin. We also measured the errors with respect to different foreground radio. From the table, we can tell that our RainNet module improved the network performance with less errors while not requiring extra parameters. We conduct a series of experiments to find the best implementations of RainNet. For example, we adding RainNet modules to the outermost layers of the U-Net, or only add RainNet to the decoder part or encoder part. From the experiments, we found that applying RainNet layers in the decoder part attains the best performance. We also compare our RainNet layers with the region normalization that lets to estimate the foreground objects without any guidance from background. The right figure depicts the convergence performance of deep image harmonization with our RainNet layers. We can easily observe that deep image harmonization with RainNet is more stable and attains better performance than the original network. Thanks for your watching.